Hey everyone, in today's video, we're going to be talking about Pascal's triangle. So I'm going to be writing out Pascal's triangle in a second, but first, each row of the triangle represents the coefficients for when you expand a binomial expression like this right here. So a plus b to the power of n. So each row in Pascal's triangle starts with a 1, and it also ends with a 1. And Pascal's triangle starts at row 0, and it goes from row 0, 1, 2, 3, 4, 5, and so on. And you can find each of the numbers in the triangle by adding the two numbers that are directly above that number. So I'm just going to write out Pascal's triangle right now. And so it starts at row 0. And the first number is just going to be 1. And that's going to be the only number because it starts and ends with 1. And our next row is going to be row 1. And there's just going to be two numbers here. And it's going to start with 1 and end with 1. In row 2, so remember, to find the numbers of this triangle, we want to add the two numbers that are directly above that number. So we're going to start with 1 as always. For this middle number, we want the two numbers directly above it, and we want the sum of those two numbers. So for this middle number, the two numbers directly above that are this 1 and this other 1. So when we add 1 plus 1, we get a 2, which is going to be right below these two numbers. And then we're just going to end with 1. For row 3, again, we're going to start with 1. We're going to add the two numbers directly above it, which are 2 and 1, which give us 3. We're going to add the two numbers directly above this next position, and that's going to be 2 and 1. And we're going to end with 1. For row number 4, we're going to start with 1. We're going to add the two numbers directly above the number, which is 3 and 1, which is 4. We're going to add 3 and 3 to get 6. And we're going to add 3 and 1 to get 4. So the number is just the sum of the two numbers directly above it. So 4 is 1 and 3, 6 is 3 and 3, and 4 is 3 and 1. I forgot a 1 because we always start and end with 1. Row 5, again, we're going to start with 1. We're going to add the two numbers directly above. So it's 4 and 1, which is 5. 6 and 4 is 10. 6 and 4 again is 10. 4 and 1 is 5. And we're going to end with 1 because we always start and end with 1. So this is the first 5 or the first 6 rows of Pascal's triangle because we start with row 0. But there's obviously more rows to Pascal's triangle. So again, Pascal's triangle gives the coefficients for each term when we're expanding the binomial expression. Oops. A plus b to the n. And another thing is when you expand, there will always be n plus 1 terms. So let's say that we have a plus b to the power of 2. N would be equal to 2, so there would be 2 plus 1 terms, which is equal to 3 terms. in that. So another thing that we want to know when expanding binomials using Pascal's triangle is when we're expanding a plus b to the power of n, the powers of a decrease from n to 0. So when you're expanding this, the powers of a are going to start at 2 and then 1 and then 0 because they're decreasing from n, which is 2, to 1 to 0. And also the powers of b increase from 0 to n. So when you're expanding a plus b to the power of 2, the b terms would start at b to the 0, go to b to the 1, and then b squared. So now let's look at some examples of how to expand binomial expressions using Pascal's triangle. So first, we're going to expand a plus b to the power of 2. And so what we're going to do is we're going to look at this 2, and that means that n equals 2. So we're going to look at row 2 of Pascal's triangle. Now remember that Pascal's triangle starts at row 0. So this is going to be row 1, and this is going to be row 2. So you're going to be looking at this row right here. So we're going to look at row 2, which is going to be, and the numbers are going to be 1, 2, and 1. So we know that there are going to be 3 terms because n plus 1 is the amount of terms that you have. So 2 plus 1 equals 3 terms when you expand. So how we're going to expand this is we're going to first do a, and it's just going to be 1 because the first coefficient is 1. And remember that the powers of a decrease from n to 0. So here it's going to decrease from 2 to 0. And b, the powers of b increase from 0 to n. So it's just going to be b to the 0. We're going to add 2 because that's our next coefficient times a to the first power because they're decreasing. So it's decreasing from 2 to 1 times b to 1 because this is increasing from 0 to 1. And then finally plus 1a to the 0 because the a powers are decreasing from 1 to 0, and b squared because the b power increased from 1 to 2. So we're just going to simplify this and we get a squared b to the 0 just equals 1, so that cancels out, plus 2ab plus b squared because a to the 0 just equals 1. For our next example, we're going to expand a plus b to the power of 3. And so we're going to have 3 plus 1 terms, which is going to equal 4 terms when we expand this. So n equals 3, so we're going to look at the third row of Pascal's triangle, which is this row right here. Because again, it starts at 0 to 1 to 2 to 3. So the third row is going to be 1, 3, 3, 1. And those are the coefficients for when you expand this. So we're going to start with 1a cubed because n is equal to 3 and the powers of a decrease from 3 to 0. B to the 0 because the powers of b increase from 0 to n, plus the next coefficient, which is 3, a squared because it's decreasing from 3 to 2, b to the first power because it's increasing from 0 to 1, plus another 3, which is our next coefficient, times a to the first power, b squared, and then finally plus 1, a to the 0, b cubed. Now we're just going to simplify this. We get a cubed, and this cancels out, plus 3a squared b plus 3ab squared plus just b cubed, because a to the 0 just equals 1. For our next example, we're going to expand a plus b to the power of 5. And this time we're going to look at row 5 of Pascal's triangle. We're going to remember that there are 5 plus 1 terms, which equals 6 terms. And then we're going to look at row 5 of Pascal's triangle. Row 5 of Pascal's triangle is 1, 5, 10, 10, 5, 1. And so these are going to be our coefficients for when we expand this binomial expression. So we're going to start with 1a, because 1 is our first coefficient, a to the 5th power, because n equals 5, and it's decreasing. The powers of a are decreasing from n to 0, b to the 0, plus our next coefficient is 5, a to the 4th power, b to the 1st power, plus 10, a to the cube, a to the 3rd power, times b squared, plus another 10, a squared b cubed, plus 5, a to the 1st power, b to the 4th power, I'm running out of space, plus 1, a to the 0 power, b to the 5th power. So as you can see, the powers of a are decreasing from 5 to 4 to 3 to 2 to the 1 to 0, while the powers of b are increasing from 0 to 1 to 2 to 3 to 4 to 5. We're going to simplify this. A to the 5th power plus 5 a to the 4th power b plus 10 a cubed b squared plus 10 a squared b cubed plus 5a b to the 4th power plus a plus b to the 5th power. And this is let me rewrite this a little clearer. This is 5a b to the 4th power. So, and this is our final answer. A to the 5th power plus 5a to the 4th power b plus 10a cubed b squared plus 10a squared b cubed plus 5ab to the 4th power plus b to the 5th power. So the coefficients from Pascal's triangle can be also found using the NCR key on your calculator, because you might not always want to write out Pascal's triangle. So there is a NCR key on your calculator, and the N is the row number, which starts at 0, and goes up, and the R is going to be the position of the term. So let's take a look at what this means. So let's take row 2 as an example. In row 2, we have 1, 2, and 1 as our coefficients. So n is going to be equal to 2. Now, the positions of each term start at 0, just like the rows start at 0. So this is going to be position 0. This is going to be position 1, and this is going to be position 2. So let's look at an example. So let's try and expand a plus b to the 6th power. So we're going to do n, which is 6, c, and r on our calculator. And this depends on which position you're in. So for the first position, we're going to do 6, c, and then the position, which is just 0, because this is going to be our first term. When we put that into our calculator, that equals 1. For our second term, we're going to do 6c1, which equals 6. For our third term, we're going to do 6c2, which equals 15. Then we're going to do 6c3, that equals 20. We're going to do 6c4, that equals 15. 6c5, which equals 6. 6c6, which equals 1. And as you can see, they start and end with 1, just like in Pascal's triangle, because these are Pascal's triangle coefficients, but we're just solving it using NCR. So now we have this, we can just expand this. So we're going to start at 1a to the 6th power, because the powers of a decrease from n, which is 6, to 0. B to the 0 power, plus our next coefficient is 6. A to the 5th power, B to the 1st power, plus 15. A to the 4th power, B to the 2nd power, plus 20. A cubed, B cubed, plus 15. A squared, B to the 4th power, plus 6. A to the 1st power, B to the 5th power, and finally plus 1. A to the 0 power, B to the 6th power. When we simplify this, we get A to the 6th power plus 6. A to the 5th power, B, plus 15. A to the 4th power, B squared, plus 20. A cubed, B cubed, plus 15a squared, b to the 4th power, plus 6ab to the 5th power, plus b to the 6th power. So for our next example, we're going to expand 3x plus 2y to the 5th power. So for this question, we're going to look at row 5 of Pascal's triangle, and we're going to write down the coefficients. So the coefficients are 1, 5, 10, 10, 5, 1. So you can see that there are different terms than a plus b. Now there's 3x plus 2y. So we're just going to substitute a equals 3x and b equals 2y. And we're just going to solve like normal, except we're just using 3x for a and 2y for b. So we're going to do 3x, which is just our a term. And remember, there's a 1 out here because that's the first coefficient. And we're going to do to the 5th power times b, which is our 2y, to the 0 power, plus our next coefficient in Pascal's triangle, which is 5, times a, which is just 3x, to the 4th power because the powers of a are decreasing, times b, which is 2y, to the 1st power because the powers of b are increasing from 0 to 5, plus 10 3x cubed 2y squared plus 10 3x squared 2y cubed plus 5 3x to the 1st power 2y to the 4th power, and finally plus 1 3x to the 0 power and 2y to the 5th power. So now we're just going to simplify all of this. So 3x to the 5th power is equal to 243x to the 5th power plus 5 times 3x to the 4th power times 2y is equal to 810x to the 4th power y plus this, which simplifies to 1080 x cubed y squared plus this, which is 720 x squared y cubed plus 240 x y 4, and finally plus 32 y to the 5th power. So for our last example, we're going to be expanding. Let's do 2x minus 5y to the 4th power. So we're going to find row 4 on Pascal's triangle, which is this row right here. And we're going to write out the coefficients. So the coefficients for row 4 are going to be 1, 4, 6, 4, 1. Now, notice that there's a subtraction sign here. When there's a subtraction sign, you're going to alternate signs. So when there's subtraction, you're going to alternate signs. And you're going to start with positive. So you're going to go positive, negative, and so on, as I'm going to show you in a second. So when you expand this, you're going to start with 1 time, because that's the first coefficient, times a, which is 2x to the 4th power. Now you're going to minus, you're going to subtract here because you're alternating signs. This only happens when you have the subtraction sign right here in the binomial expression. When you have a positive sign, just keep everything positive. So we're going to subtract 4, which is our next coefficient, times 2x cubed, 5y to the first power, plus our next term is 6 times 2x squared, 5y squared. And we're going to subtract again, minus 4 2x to the first power, 5y cubed. Oh, and we're going to plus 1 times 2x to the 0 power and 5y to the 4th power. So now we're just going to simplify all of this. So 2x to the 4th power is 16x to the 4th power. This right here is negative 160 x cubed y plus this, which is 600 x squared y squared. We're going to subtract again, minus this, which is 1000 x y cubed, and finally plus 625 y to the 4th power. So that is it for today's video. I hope you enjoyed, and I'll see you in the next one.